Hi everyone, and thank you very much for joining. In the following session, I'm going to talk about observability in serverless applications. And I'm Ran, the co-founder and CTO at Hexagon. Also, I'm an AWS serverless hero. So let's get to know a bit better. As I mentioned, I'm the CTO at Hexagon. We're doing exactly observability for serverless and microservices running on cloud. I'm an AWS serverless hero, which means that I really like to speak about serverless and the ecosystem and architectures and so on. So feel free to ping me at any topic, any point regarding cloud. Also in the picture here, you can see me looking for whales, but unfortunately that didn't go so well. And you can feel free to follow me and DM me on Twitter. It's open for everyone. So let's get going. In the following session, I'm going to talk about monitoring and logging, which are pretty straightforward, but I think there are some things to make yourself comfortable with. Also, I'm going to talk about the broader term, which is called observability. And then I'm going to touch specifically on distributed tracing. So first thing when we're considering monitoring, we need to know what actually are we monitoring. And I think the golden signals, the 4 golden signals that Google defined in their SRE books really states good what we should monitor. And this comes with latency, traffic, errors, and saturation. So most of them are pretty straightforward. Things like latency, how long it takes for a request to be processed, for the user to wait, in other words. The second one is traffic. How much traffic do we get? Is it more or less than we used to get? And obviously, how many errors? Because this is a very important signal that we need to look for and make sure it's as zero as possible. Now, another one is saturation, which most of us tend to miss because it's not pretty straightforward to understand what saturation. Let me put it in a simple word. Saturation is how full is your system. So even if the 3 other signals are good, it might indicate that very soon if you'll hit some more traffic or a bit some more errors or more latency, something will go wrong in your system. So that's exactly saturation. Now in traditional kind of monitoring, as you can see on the right hand side, we used to have some business logic that exposes some REST API and communicates to some database. In this kind of environments, to gather some metrics or monitor it, I would need some agent that run on the specific host. This agent would usually collect some host information like CPU, memory, network, and some other vital signs. But the main problem with this kind of agents, except for the part that you need to install them obviously, it's that they collect only metrics. Now metrics are good, but metrics can just tell us some symptoms of something that happened. And we need to drill into something more elaborative. Especially when we're troubleshooting, we need some more debug data, or in other words, we need logs to understand why the problem happens. So with traditional logging, again, there is another agent, usually some kind of a shipper or some kind of this agent-based approach that dumps all the logs either locally in the more traditional applications or even remotely to a centralized logging solution. Can be like Elastic or Splunk or some other solutions as well. The main inherent problem with logging is that whatever that you're not logging just won't be in the logs. So it means that you're responsible to put anything inside the logs that you want to investigate afterwards. Now that we have some ground up, let's try to move into the future. And in the future, as we already know, applications are getting more and more complex. They're moving within 2 parameters. One of them is where they're running, and the other one is what's the composition of the application. So if we used to have host-based monolithic applications, now we found ourselves with abstracted hosts, managed resources, third-party APIs, and a highly distributed application. So it means that instead of one piece, we have hundreds of pieces, including message queues, databases, storages, web servers, third-party APIs, function as a service, container as a service. It makes every single component much simpler with the ability to ship individually or separately, which is great. But then when you're trying to build a piece of all of the application inside your head, it's just getting more and more complex. And this is a very simple and straightforward example, but imagine yourself what it would be to troubleshoot such an application. Now, the challenges that us, the engineers and the DevOps are facing today is starting with troubleshooting, understand how do we correlate between what's going on inside our application, inside complex flows and event-driven applications. Also to observe, just to look at what's my overall application looks like, what's changed between version 1 and version 2, and even go to an optimization process where I know where are my bottlenecks and how can I improve my application, and in other words, improve my customer experience or my customer journey inside my application. So all of this becomes really, really problematic when we're going to serverless or we're going to the modern applications. And especially for that, the three pillars of observability exist. And let me give a few words about what's observability. Observability, in other words, means metrics, logs, and traces, or anything that would help you understand your application, whether it's development or production or even subset of the application. And what we saw so far is that we're collecting metrics and logs. Metrics tells us what's the problem. For example, lack of CPU, lack of memory, too much network overhead, and things like that. The logging will tell us why it happened. For example, there is lots of CPU because this specific operation takes very, very consuming to the CPU bound operations. And then the missing part that we haven't talked about is tracing, where the problem happens. Because now every resource is individually doing something, but it's part of a bigger picture. And the tracing is the thing that tells us what's the bigger picture. And it's really important to have everything under the same dashboard, under the same tool, not metrics in one solution and logging in another solution and tracing manually being done. Tool separation really kills the productivity of the teams because now each one is throwing the blame at another team and what they did, and we want to have the ability to collaborate under the same tool to gain observability in a single platform. Now, before I drill into the distributed tracing, I want to share some best practices in logging and metrics and so on. So let's start first with logging. I think that the first and foremost, helpful tip within logging is to print out JSON or structured logs with metadata. Instead of just printing raw lines of what happened in the code, try to print a JSONified or structured kind of payload that also tells us what's the resource that we're having, what's the name of the service, what is the stage that we're running at, what's the time frame, what function are we running at. Lots of information that will help us afterwards to index and search by that, which leads me to the third point, that once we're having a system in place, a logging solution in place, I can say, show me that log that is running in production on that specific service, and not just randomly looking for tons of logs which are not structured in any way. It can also help me, to compose analytics based on this information. Now, the second tip is also super crucial because, as we mentioned, it's manual to create logs. It means that if you're the developer, haven't printed out some logging information, it's just not going to be in the logging solution. So we try to automate as much as possible the process of logging, or in other words, try to use middlewares. Middlewares inside your functions, inside your applications, your Flask, your Express, your Django, your Spring application, as much as possible that will try to cover all of the information and will just put it automatically out to the logging solution. Now, in terms of the monitoring best practices, so first and foremost, try to aggregate all metrics into the same dashboard. If you're finding yourself having dashboards in solution X and Y and Z, and you need to combine what happened in the database metrics in there, and then what happened in the function metrics in there, and then some custom metrics in some other solution, you're really missing the point, because you want to be able to correlate between all of the metrics, obviously between the metrics, the logs, and the traces, but even just within the metrics themselves, you want to combine all of them together. Now, with monitoring, I've seen so many times organization alerting too much or creating this kind of alert fatigue that every small problem goes to the solution of the incident management, and at some point there's just so much of it that you can't follow what's going on. So in this case, make sure to define critical thresholds or critical metrics for you, because that's the thing that you want to wake you up in 4 a.m. in the morning. It's better be worth it and better happen not every morning or not several times a day. Also try to ship custom business metrics, because the business metrics are relevant for your business and ultimately your application serves your business, but I'm going to touch point on that when I'm getting to the distributed tracing part. Now, the last piece of monitoring the application or monitoring best practices is to look at the application as well. Many times I find myself with organizations that are just saying, hey, we're monitoring CPU, we're monitoring network, memory, we're all set, everything is good. So no, that's not good at all. You gotta monitor your application level metrics as well. Things like what's the average duration or even percentile of calls to your specific API, or what's the number of messages that are coming into your message queue to see how much volume are you having, or even number of 500 or 400. That's something that you'll need to define for your own application, but these are just some examples of things that you want to look at your application to make sure that you're providing good experience and resilient system for your customers. Now, even with all these best practices, something is still missing. And first and foremost, how do we correlate between metrics and logs? We're shipping logs, we're shipping metrics, each one of them lives on another platform. Now, how do I know how to correlate between these two? And ultimately, how do I correlate between data in different services? Like, how do I know what service A communicating to service B? How do I know the connection between them? This is still missing. I'll need to do something in order to make it happen, make it connect. So with that, that's exactly a good segue for distributed tracing that can help us with these two major topics. Distributed tracing, in a very simple way, it's a story. As you can see on the right-hand side, I don't need to explain really what happened. You see the flow, you see the numbers, you know what's going on when it comes in and out from a service and what is the path. So ultimately, a trace just tells a story. That's it. Now, in order to generate traces or in order to do distributed tracing, there are several open source tools that can help us to accomplish that. And it differentiates into two kind of categories. Some of it helps us to generate traces, same way as we generate the logs. And the other part is to ingest and have some client to visualize the traces. Again, pretty similar to logs. You create them and you ship them to somewhere to do something with them. So for the first part, we got two cloud native or CNCF projects, Open Tracing and Open Telemetry. And for the ingestion and client, we got Jaeger Tracing, and Zipkin. Jaeger is also part of the CNCF. So let's drill into actually what it means to do distributed tracing. First part of generating the traces, this is probably one of the most complex parts, because now you need to go everywhere in your code and start to change it or alter and annotate your code in order to generate traces. So the process to do that is first to instrument every call. In other words, every time there is an HTTP call, for example, you want to capture the request and the incoming response, so you'll be able to understand what exactly happened. This instrumentation means that you need to go for every library, for every framework, for every code language that you're doing to capture this information, to understand exactly what happened. Now, once you're capturing this kind of operation, you need to create a span. Span, it's a part of the open tracing terminology and also open telemetry terminology. Spans defines a very simple thing. It defines an operation that started somewhere and happened for a duration of time. So like an operation that took place somewhere or something that is doing. Now, since having just such limited information on a span, it's not good enough, we can add context to that span. Context, it's like metadata. What happened, for example, if I'm calling an HTTP resource, what was the endpoint that I'm calling to? Or what was the response status code that I'm getting? And any information that I want to enrich with the specific span. Ultimately, I want to inject and extract IDs when I'm moving between services. For example, if I'm making an HTTP call, and this is the main part of distributed tracing, being able to understand distributed traces altogether. So let's say I'm making an HTTP call, which apparently is an API gateway which triggers another Lambda function. I want to be able to connect between these two requests, Lambda, API gateway, and another Lambda. So the first Lambda needs to inject some kind of ID into the HTTP, somewhere in the headers, for example, let's call it correlation ID, that will go into the API gateway and then into the Lambda function. And the second Lambda function needs to extract this ID. The Lambda function, the B Lambda function, need to look for all the headers and say, is there any correlation ID? If there is any correlation ID, let's extract it and understand exactly what part of a trace am I. And if not, I'm just going to start a new span, a new tracer object. Just so you'll be aware with some example, this is an example in Python, in open tracing, how to create a trace for an incoming request. I'm talking here about lots of codes and lots of additional code and implementation that you need to do. That's not an easy task at all. You'll need to review that, you'll need to train your engineers how to do that, or yourselves. That can be a very heavy lifting work that, if you're going serverless, that's not what you want to do. You want to build your application and not build an observability solution. Now, in terms of the ingestion and client, once we generated the traces, we need to ship them somewhere. So we need, first of all, a system that can ingest according to our scale, millions or billions of traces or spans every day. We want to have something that will allow us to index the context, the tags for easy search, for aggregations, for anything that we want to do. We want to visualize the traces, either in a timeline that will tell us how long things takes, or even in a graph view that will tell us, what's the path that the request is going through in a simple visual way. We want to be able to set alerts. We want to do many things with that kind of system. And today, Jaeger provides a very limited way to do so. The best thing that it's doing is just to visualize the traces, but anything on top of that, you'll be able to implement on your own based on Jaeger. But again, that's not the thing that you want to do. And look over here, it's very nice to see, instead of tons of logs, to see actually the operation and how long it takes and where do we got some errors or not. So this is really simplifies the observability or understanding of our system. Now, few best practices about distributed tracing. First and foremost, you want to tag your traces. You want to add some tags or context that will help you understand and will help you do complex things. Things like identifiers, for example, which user ID am I treating right now, or customer ID or device ID, something that at some point, if I'll have some problem, and I'll probably have some problems, I'll be able to pinpoint the exact transaction, exact user ID that experienced this kind of problem. Also things like flow control, like how much times am I doing operation X or Y, or how much time am I doing business logic X or Y. Now, as we spoke about business metrics, this is where it comes super handy, and especially with solutions like Epsagon that helps you to visualize this kind of metrics and set alerts on top of them. You can start to build your own dashboard with business metrics. For example, for every time there is a checkout, to visualize and understand what's the average items in the cart when somebody is doing a checkout, or how many minutes watch over a video that you're having. This becomes the most important part because this is actually your application running. Business metrics are your business. So if you're just monitoring the application, it's good, it's very good. But if you're also monitoring using your application, your business data, this is the state-of-the-art monitoring that you need to inspire to. Now, let's go even a step forward. Why just to tag some traces and not just to put all of the payload? And again, this is you're probably saying there's tons of data, how do I store this? That's right, but that's exactly why solutions like Epsagon exist, that it will take care to automatically ingest everything and will store it and will index it. And it can be so crucial when you're troubleshooting. For example, when you're making an HTTP request to a third-party API and there's an error, you want to understand quickly what's the error, looking at the body, the response body or the request body, what went wrong. Or when you're calling to a database or a MongoDB or a DynamoDB or an RDS, you want to see the key or the query that you're having. That will help you troubleshoot very easily. So everything encompassing the full payload of the trace is super important. And again, with solutions like Epsagon, it comes out of the box, so you don't need to carry about how much data am I shipping or what's the size and so on. And ultimately, that's a very strong part. Tracing can tell us what are the logs that we're having. For example, if a Lambda function fails and I'm seeing the traces, I want to see also the logs. And even not just the Lambda function, something that is running on containers or on anything else. And also correlate between the trace and the environment. If I'm running something on a Lambda function, I want to see the corresponding traces. And vice versa, when I'm looking at the trace, I want to see the actual metrics for the environment for the Lambda functions. So Epsagon is the only solution that actually combines or fuses and correlates everything all together for you. So troubleshooting becomes very simple. You just look at everything under the same dashboard, which is very unique. It's a different kind of approach to understand or gain observability into applications. Now, just to sum it up in terms of observability, I want to just review some of the best practices for observability in your organization. So first and foremost, this is the most important, and especially since we're on a ServerlessDays event, the first and foremost thing to notice is to have as automated as much as possible without any maintenance solution. If you're going to pick a solution, you don't want to work for it, you don't want to train yourself what is a trace or how do I set up something or how to set up a collector or anything else. You just want to plug and play. That's what you're doing with your DynamoDB, that's what you're doing with your Lambda function, your API gateway. That's exactly what you need. So this is, I guess, for me, the top priority when I'm choosing a solution. Now, second thing is obviously to support all of my environment components, things like AWS resources, function as a service like Lambda, Kubernetes, ECS, anything that I'm having, I should be able to visualize. If you just give me a solution, just for Lambda functions, but I'm having also half of my application on containers, I need to see the bigger picture, and that's very crucial. Now, something that will connect every request, if it goes through a DynamoDB stream, API gateway, Kafka, Kinesis, S3 buckets, everything should be connected all together. And something that will be able to search, analyze, pinpoint, help you actually to observe your system, not just to build another nice dashboard, but actually help you on your day-to-day routines, whether it's development or production. And here on the right-hand side, you can see a nice example from Hexagon for an application that's running fully on AWS with Lambda functions and Stripe and Java and Python and, a combined application that really simplifies. Now you understand exactly what's going on in here. I don't need to explain you what am I calling or what was in the body or what the path that the request went through. And I can see all of the logs, metrics, and information under the same dashboard. Now, the journey to observability, if you're right now at home, probably like thinking, how do I do observability to my organization? So I've gathered a few steps for you to get started. First, identify your business goals and the architecture that you're running. So if you're saying, I'm not having any problem, all seems to be good, and my scales probably will remain the same as I'm doing now, don't look for any solution. Don't force yourself to bring something new. But if you're lacking from long troubleshooting time, from painful time to troubleshoot or to understand what happened, from lack of understanding the system when even a new engineer comes in, or being able to compare version X to version Y in your application, you need to understand exactly, this is your business goal to improve that, and understand what's the architecture that you're running. Is it completely serverless? Is it a hybrid application? What's the mixture of what you're running? Now, you'll need to understand whether you want to implement it yourself or pick a managed solution. Here I'm very biased, obviously, to pick a managed solution. Do it yourself is also good, but unless you're a really, really big organization, I'm talking about, thousands of engineers across the world, that, picking a solution can be painful, and implementing, you need your own customizations, you need the ability to, to build it on your own. That might make sense. But any other case, it will just take you months or even years worth of engineering time and long implementations and constant maintenance and training. So just go with a managed solution. In 99% of the cases, it will be much cheaper and much better than what you'll build on your own. Now, trial several solutions. Don't just pick with one. Try to compare them where the strengths and weaknesses, and understand what gives you a better picture, better overall observability solution. And make sure that it integrates into your existing ecosystem. For example, if you're shipping alerts to PagerDuty or VictorOps, make sure that it works. If you're working with Slack or Teams, make sure that it will go there. So make sure that the existing solution fits what you're currently having and doesn't force you to change all of your stack to something else. So just in summary, I think that you all understand now that modern applications, especially serverless ones, requires more than just monitoring or just a logging solution that we need to, sift our way through the logs to understand what's happening. And distributed tracing really becomes probably the major part in our applications today, that, it's an important and crucial component for every observability solution. And I think for you out there, try to stop implement your own solution. I know that it's very fascinating to learn about tracing and start to implement your own solution and do one step at the other, but then you end up with a solution that doesn't work really good, and somebody needs to maintain it. Just try to at least evaluate some solutions that already exist and doing their best at observability. And just for all of you, everyone that joins the Serverless Days, feel free to get into hexagon.com/SLSdays. You'll get nice benefits and free monitoring, insights, and alerts to your Lambda functions, ECS, containers, Kubernetes, and much more. So feel free to join today and get some nice swag. Thank you very much, everyone, for joining. I hope that all of you are staying safe, and feel free to send me any questions or DMs through all of the mediums that I've mentioned. Thank you very much, everyone.